name is Professor Mark Wallace, and I'm going to be talking about workforce management, shift work, and fatigue. The challenges in alert safe rostering, so that's rostering to avoid any instance occurring and due to tiredness, has three parts really. There's a rostering challenge, there's a risk of incidents during shift work, which have to be minimized, and there's physiological models of fatigue, which have to be modeled in the rostering. I'm going to talk about these three aspects now. First, the rostering. So a roster is a set of shifts over a time horizon, and those shifts each day might be on a day shift or an evening shift or a night shift or having a day off. But for each shift that's set up, there must be a number of people working on that particular shift at that particular time on that particular day to cover the needs of the organization. That might be a number of people with specific skills or an appropriate mixture of skills and experience. Moreover, each staff member in the workforce will be on a sequence of shifts happening over a week or a month, which must provide sufficient work for that person, but not too much work. There must be time to rest, and they must meet certain requirements of the worker themselves. Maybe you're not working too many weekends, or not working on a particular day, their birthday or whatever it is. And finally, for all the workers, there must be a balance so that some people mustn't end up working every single weekend while others don't work weekends at all. So when you look at a real application, for example, in a hospital, you'll find that the people involved in the shifts have quite complex preferences. They may not be able to work on a Thursday afternoon because of whatever, or they may only be able to work certain weekends, or they work last Christmas so they can't work this Christmas. There's not only preferences, but there's also the requirement at the last minute people become ill or for whatever reason they have to swap shifts. And so the ability to swap shifts must be supported as well, ensuring that the person who takes on that shift is not going to be overloaded and doing two things at once. But finally, and perhaps hugely importantly, you've got to be able to respect the previous processes, the current processes for rostering, so that the person who's doing the rostering must be able to do it in the same way. The nurses must be able to express their preferences in the same way. They must get notified about changes in the same way. So rostering is being studied within a large cooperative research collaboration. And this is a 7-year collaboration that, on the Alertness that we've been involved in, involving a number of universities as well as a number of industry partners. And for Alertness, there was a modelling of the neurophysiological state, so modelling of the brain of people on shift work, in things like sleep laboratories where people were actually watched as they slept to understand what was happening in their brain. But also, the CRC developed innovative and new optimization algorithms for rostering, and in particular, an integration of rostering into the modelling of fatigue that was performed also within the CRC. And I can't talk about rostering without talking about change management. So what happens when you go from the old method of rostering to a new method, maybe with support of an IT system? This creates a major challenge for the people involved. It's a challenge for the people being rostered, who may have a lack of trust of a computer system. It's a challenge for the unions, who may say, well, there are certain agreements and they've got to be maintained by that automatic system. It's got to be proven to do the right thing. There's a challenge in terms of the IT department, who are used to having certain kinds of suppliers and certain kinds of software and may not trust a new supplier or any kind of software. And of course, there's a major thing for the shift workers themselves, who may feel that their own preferences are not going to be sufficiently taken into account. So in any change, it's a challenge, but in rostering, change management is a very, very great challenge. So we talked about rostering. I now want to talk about incidents during shift work. So really, I'm talking about looking at the past of what incidents have happened historically during shift work. And this little cartoon, it says, at first, I thought it was just a coincidence. And then I noticed it corresponded perfectly to your shift. So there are many reasons for incidents to occur. One point of note is that some of the major recent industrial incidents have occurred in the early morning. So a couple of nuclear disasters at 3 Mile Island and Chernobyl, the chemical spill at Bhopal and the oil spill at Exxon Valdez. And here's a picture of the Estonia ferry, which capsized in the middle of the night. Statistically, then, you can look at what incidents occurred in what shifts under what conditions. And in this first summary, we can see on the right-hand 3 columns where it says morning, afternoon, night, we look at the relative risks. So if the morning, you say set the relative risk at 1, we can see that in the afternoon there is a greater risk. So maybe 20% more in the first row. And at night, the risks are even greater of incidents happening on shifts. That's just based on historical data. Again, if you look at sequences of nights, so if you set the first night at the risk at 1, then you see that the risk increases on the second, third, and fourth nights. So it goes up to 70% higher as you get to multiple nights following each other. So that's to do with the circadian rhythm being out and increased tiredness due to this ability to adapt to night work. If you also look at the duration of a shift, you again see a dramatic increase in the risk that occurred for longer shifts historically. So up to 8 hours, the risk stays reasonably steady and then increases dramatically up to, and above 12 hours, increases even more dramatically. And finally, you can look at the risks of certain shift lengths happening repeatedly over a sequence of days or nights. And so 6 nights is much worse than 6 days, and of course, even 4 12-hour nights is the worst possible. So looking at estimates of risk based on historical statistics, as we've been looking at over the last few slides, it's great that it's evidence-based, and it can handle different shift durations, it can handle the time of day, it can handle breaks, and it can look at the age of the people where the incidents occur. But the drawback of historical studies is that they can't deal with unexpected variation. So they look at data that was recorded, and often the data is incomplete, as you see below. But also external conditions vary a lot in different situations. And so when you're looking at a future shift pattern, you don't find easily external conditions historically that match the conditions of your particular shift pattern. We might find very few matches, which makes the statistical evidence very insecure in terms of what it can predict for the risks that. And that's a reason to look at physiological models of fatigue, so trying to understand actually how fatigue occurs and grows. And the physiological model that was worked on in our Cooperative Research Centre had 6 major parameters. Some of those parameters were governed by the circadian rhythm, so that's how we change over a rhythm of days and nights. So it governs our need for regular sleep, which is roughly 24 hours. And it's affected by light, so if you have more light, then you stay awake better. But the circadian rhythm shifts quite slowly, so that you can't just move into a night work and immediately have your circadian rhythm matching the night shifts. The other parameters represent or reflect the fatigue state, so it's essentially increased with time since the last sleep. And the brain can suddenly flip from a state where you're staying awake to a state where you really find it extremely hard not to just fall asleep on your computer. And this fatigue state is affected by the intensity of activity, and it can be temporarily relieved by things like coffee. So, in order to do alert, safe rostering, we need a very powerful rostering algorithm. We need to match evidence-based risk estimates, but we need to integrate physiological and evidence-based historical measures of risk into shift patterns determined by the rostering system. So we've got to integrate alertness and rostering. And this has not been done before, but Opturion has combined all three.